All right, so let's talk about some more unit conversions, but let's talk about a special case where sometimes you have to work with conversion factors that are dimensionless. In other words, it's not really clear how they relate to separate, uh, two equivalent values expressed in different units. Okay, so I think that the easiest way for me to introduce this idea is just to simply ask you a word problem. Okay, so let's imagine that we have a power plant. The power plant takes in a certain amount of fuel energy and it outputs a certain amount of useful energy, usually in the form of electricity. Okay, and we're going to assume that we have a power plant that's 30% efficient. All right, so it converts 30% of that input energy into useful output energy. My question for you is, how much fuel do we need in order to produce 10 joules of useful energy output? So how much fuel do we need to produce 10 joules of electricity? And for those of you that aren't familiar with this unit J, it's a joule, and it's just one of many units of energy we could work with. Okay, so first of all, how do we use this number? And second of all, what the heck do we do with this weird conversion factor that we haven't really worked with before? Okay, so I think to begin with, I think it's important to figure out where this 30% comes from. This 30% is essentially a representation of the ratio of energy output to energy input. In other words, if your power plant outputs 30 joules of useful energy and requires 100 joules of input fuel, that's going to leave you with a ratio of 0.3. And we oftentimes express these decimal numbers as a percent by multiplying them by 100. So this ratio being equal to 0.3 corresponds to 30%. So basically, this 30% is saying that 0.3 is equal to the ratio of useful output energy to the initial input energy. Okay, so 0.3. And it's this 0.3, this ratio, which is also going to be a conversion factor for us, is dimensionless. Joules divided by joules is nothing. Units cancel. That's dimensional analysis. So how do we use this? Okay, and how do we relate it to this number? Okay, so numbers like this, these dimensionless conversion factors, are still conversion factors. The way we answer this question is just a unit conversion. And we could imagine that we want to get from 10 joules of energy to another amount of joules of energy. But this second number is going to correspond to the amount of fuel that went into the power plant. All right, so my strategy for doing problems like this and working with percentages is to sort of, manipulate your own reality a little bit. I want you to, or at least what I do in these types of situations, is I will actually create my own more specific units that allow me to distinguish between the units that I'm starting with, or the value that I'm starting with, and the type of number that I'm trying to get to. In other words, since I have two different types of energy input in terms of fuel and energy output, probably in units of electricity, I'm going to try to distinguish between these two so that I can start with units of electricity output and work my way back to units of energy input. Okay, so let's do this. Let's say instead of just using joules, I'm going to distinguish between joules of power plant output and joules of fuel input. Okay, in this case, I'm starting with joules of output, and I'm trying to work my way back to the amount of fuel that goes into the power plant. What this means is I need a conversion factor that has my new units on top and my old units in the denominator. So in other words, this is going to be fuel input, and this is going to be fuel output. And now I just need to figure out how to use this 0.3 and manipulate it into a conversion factor that works for this. All right, but as we saw before, 0.3 is a conversion factor, and it's basically, I'm going to rewrite this. We have 0.3 joules of output per joule of input. 0.3 units of energy output per unit of input. Okay, but what I need is a conversion factor that has units of input energy in the numerator and output energy in the denominator. So I'm going to think about it this way. I could think of this conversion factor as 0.3 joules output for every 1 joule in. And I could create another conversion factor just by finding the inverse of this. So 1 joule of input is equivalent to 0.3 joules output. And this is a conversion factor that works really well for this problem. So 10 joules of output times 1 joule in for every 0.3 joules out. This works beautifully because energy output cancels out with energy output. We're left with energy input. And we end up, by actually dividing these numbers out, we end up with like 3.33 joules of input fuel. I'm sorry, 33.3 joules of input. Hopefully my mental math is correct there. I think I got it the second time around. All right, so we've answered the question. How much fuel do we need to produce 10 joules of energy? The answer is 33.3 units of energy in terms of fuel. And by breaking up this dimensionless conversion factor into more specific units that are tailored to the question we're trying to answer, we were actually able to use this percentage as the conversion factors that we've looked at in previous videos.